All right, now we're going to look at regression on your Casio calculator. Regression is when you have a bunch of data points, usually from a scientific experiment or from a survey from real life, and you want to find the best line or curve that fits your data. And to do this, we're going to use the statistics part, a statistics menu on your calculator. So to do that, we're going to go to menu, and number 2 says stat, statistics. So pick option number 2. And this gives you a place where you can enter all your data points from whatever your experiment is into your calculator, and we're going to graph them in a minute. So in this case, we are looking at sandwiches. Somewhere along the way, we did experiments on a whole bunch of different sandwiches to find out how much fat was in each sandwich and how many total calories were in each sandwich. So a hamburger, 9 grams of fat, 260 calories. Cheeseburger, 13 grams of fat, 320 calories, and you can read down the list. Quarter pounder with cheese, Big Mac, arch sandwich special with bacon, crispy chicken, fish fillet, grilled chicken light. Ooh, grilled chicken light, only 5 grams of fat, but still quite a few calories. So what we're going to do with this is we're going to put into our list 1 all the information that is in column 1, and in list 2 over here, we're going to put all the information that is in column 2. If you have things already in here that you need to clear out, you can always hit the over button, and it says del A, that's your delete all. That would delete everything in the list, clear the list so you can start over. If there's nothing in there, you can just start typing. So I'm going to put my first number in, put a 9 in, hit enter, 13, keep going, 21, keep going, 30, 31, 31, 34, 25, 28, 20, and 5. Now I'm going to go over to my list number 2 and put in all the numbers in column number 2. So 260, 320, 420, 530, 560, 550, 590, 500, 560, 440, and 300. You can kind of give it a once over just to make sure that you've not typed in any numbers incorrectly quickly, and if you need to, pause your video and finish typing in your numbers if I beat you there. So now that we've got all our numbers into our stat spreadsheet, now we're going to graph them as points. So this is like my x-coordinate and my y-coordinate to see what they look like. So I'm going to choose F1, which is graph. And then it gives me a couple options of which graph that I want. So right now I'm just going to choose graph 1, and it automatically chooses a nice friendly window for me, so I don't have to worry about friendly windows. And we've got all these are all our dots from our experiment. There's a few things, if you want to, that you could play around with. If we just go back, if I want to go back, I'm going to hit this G. No, I'm going to hit, what am I going to hit? Ooh, exit. Gets me back to my main list. I can set up if I want to. I can tell it which list I want to be X and which list I want to be Y. I'm going to leave this as a scatter plot. That's what it's called when I graph a whole bunch of points from a list. And I can choose if I want them to be open squares, X's, filled in squares. Maybe I'll just make them X's just for fun. Hit enter, go back to my graph. Now they look like X's instead of looking like squares. It's up to you what you want them to look like. You can just kind of play around with those settings. Don't really want to change much though. So again, to get back, we're going to hit exit. That would take us back to our table. Hit F1 to get back to your graph. Now that we've got that, what we want, this kind of looks like a linear relationship. In other words, the more fat that we've got, the more calories that we've got. So it's not exactly a straight line, but it looks more or less like a straight line. So if I want to find the straight line that fits this data, I'm going to hit my F1, which says calc. And then I'm going to choose this F2 that says X. In other words, I want an equation that has an X in it. And my other options are X squared, X cubed. Don't worry about this med for now. And I can keep going over to see what my other options are. But I just want a straight line, so I'm going to choose X. And it tells me right away, this is what my line would be, my line that fits, where y equals ax plus b. They're using an a instead of an m for your slope, but it's the same thing. So my slope, my a, it's telling me is 11.7312808, and my y-intercept, my b, is 193.852147. Now, if I just want to see kind of how that fits with the dots that I've got on my graph already, I'm going to hit this that says draw, and it will put there's my equation drawn on my graph. So that's how I get my linear regression on my graph. Now, unfortunately, there aren't a lot of options from this menu in terms of finding different points or finding your y-intercept. I can trace it. No, I can't. I hit the wrong button. Oops. Graph, calc, X. There it is. Gonna draw it. I can't even trace it. Oh, yes, I can. I can trace it. If I hit shift first, shift trace. If I don't hit shift first, then it automatically thinks that I wanted to calc this 2-bar, which is not what I want. So if I hit shift trace, I can trace along it, but it doesn't let me type in anything, go to a certain spot. It just lets me basically go back and forth along the line. So if I want to be able to do all my normal fun things, finding different X values, what my Y values are, I'm going to hit exit, go back to my graph, and this time when I calculate, instead of saying draw, I'm going to say copy. I want to copy this information, copy this equation, and it takes me, now this is my normal graph menu, and it's going to copy it into whichever one of these I select. I'm going to put it into Y1, and once I hit enter, it will automatically appear there, but I'm going to go disappear actually. It goes back here. Maybe I'll draw again. So now if I go to menu and I go to number 5, my graph, there it is. This is the equation that was copied in from my scatter plot. So now when I graph, I'm fine with that equation. I either need to start editing it, that's what I did, and hit enter, or you can also go onto it and hit SEL, which says select. It needs to be highlighted. If it's not highlighted, then nothing will draw. So right now, if I hit draw, nothing's going to appear. So I want to select it and hit draw. And it kept the same V window as I had for my scatter plot. So this is the V window that will fit this data. If I want to find out what it is, I can go Shift V window and see that my X min is 0.1, almost 0. My X max is 39, more or less, and Y min 150, Y max 700. So I can leave it like that for now and go back to my graph. And the whole reason that I want to put this onto my regular graph menu option, is so that I can complete the next 2 parts of this. So using this line now, we want to predict the calories of the grilled cheeseburger. So grilled cheeseburger is not in this list. It's a new burger. What we know about it, it has 79 grams of fat. Ooh, it's very, very fatty. So we want to be able to predict how many grams of fat, how many calories it has if we know it has 79 grams of fat. So usually when we do that, we're going to hit trace, then we can type in our 79. And the reason it's giving me an error right now is because my V window doesn't go that high. So I'm plugging in this 79 grams of fat for my X value, but my V window doesn't go far enough. So I have to change my V window to go at least this high. So I'm going to exit out of there, go back to my V window. Right now, maximum is 38, so maybe I'll go up to 100, just because I can. And now when I go back here, go zoom way off the graph. So whatever I want, it's going to be at 79. It's going to be somewhere over here. So I need to make my V window higher as well. So we're already at 700. Maybe let's go all the way to double that, 1400. This is kind of trial and error. Enter, draw that again. Oh, look, actually that's pretty nice. So to find 79 grams of fat, again, I'm going to hit trace, type in my 79, hit enter, and it tells me that the grilled cheeseburger, which has 79 grams of fat, we'll have about 1,120.623 calories. So let's just write down that number, 1,120.623 calories. So that might not be exact. Remember that not all our data points when we were in the stat menu fell exactly on this line, but this is my prediction based on my line that best fit those scatter points of what amount of calories a 79-gram burger would have. Now we're going to go the opposite direction. Using my best fit line, I'm going to predict the fat grams of an 800-calorie sandwich. Remember that the calories is your y, and in order to find a y value for a given x value, we're going to go back here, and we have to type it into y2. So I'm going to type this in as 800, draw that, and then I find the intersect. So I hit gsolve, intersect, and it tells me an 800-calorie sandwich would have 51.669 grams of fat. All right, so again, this line was the best fit for my stat plot. So that was menu 2. I'm going to graph. So this information, these data points were best fit by this line that ran through the middle of them. And we can use this line as a predictor for other data points that we don't actually have. So linear regression is one of the most common types of regression where we find the line that best fits our data. There are other types of regression though. So we're going to do a really quick review of different kinds of graphs. You should be familiar with what these look like. Your quadratic we did lots of work with last year. This is your U-shape. And it is also, if it was upside down, could be upside down U-shape. So this kind of a relationship, maybe your data points are all gathered like this, or it could just be around 1/2 of it. You just never know. So this kind of a shape we use for quadratic regression. Your square root function looks like this, or even if it was upside down like this, so you can imagine if it's going this way, but the basically square root function is 1/2 of a quadratic, but on its side. Your cubic function looks something like this, or it could also come up from that side, something like that. You can flip it over, flip it around, but those are your basic cubic shapes. We're going to do a lot more work with this later on this year, but these are the basic shapes that you should recognize. And your exponentials, which we also did a fair amount of work with last year, looks something like this: exponential growth, exponential decay, depending on if your base is a fraction or not. So we use these a lot in regression. And you'll notice that you had different options for regression. So this was your linear regression. X squared is your quadratic regression. X cubed is your cubic regression. If we keep going, they even have x to the 4, which we didn't bother to draw here. We could do a logarithmic regression. So remember, your log looks something like this. This would be your log function. Exponential is going to look like this. We won't worry about power function or sinusoidal functions yet, or logistics. So we got different options for regression, which leads us right into the next example. The table below lists the number of Americans in thousands who are expected to be over 100 years for selected years. So in thousands, number in thousands, so 50 means 50,000, 56 means 56,000, 65 means 65,000. So in 1994, there were 50,000 Americans over the age of 100. 1996, there were 56,000 Americans over the age of 100. So we want to put this information into our stat plot. We're going to go back to menu, stat, and I'm going to exit back. Remember that I said if you already have stuff in here, well, you can always exit to get you back to your main menu. If you have stuff in here and you want to delete lists you already have, we're going to triangle over to the next list and hit this del A that deletes everything. So yes, I want to delete it all. Same thing here, yes, delete it all. So I have cleared out my list, and then I'm going to put in this new information. Now, usually when we have one of our data is in years, Instead of actually typing in 1994 or 1996 or 1998, we call the first year year zero, and then we just count how many years since this year is the next year. So 94 to 96, so this would be like year two. 94 to 98, that would be year four. 94 to 2000, year six. You get the idea, counting up by twos. So instead of putting the year directly in, my x is now going to be the number of years since 1994. So instead of putting 1994 in here, 1994 is year zero because it's been 0 years since 1994. Then I have year 2, 4, 6, 8, and 10. And moving over, list 2, I'm just going to put 50, not 50,000, 56, 65, 75, 94, and 110. So I put my information into my plot, and I'm still on the delete all. If I want to go back to the previous menu, I'm going to hit the arrow over again. And the first question asks you to find the friendly window to view the scatter plot. So your calculator actually does this automatically. Lucky you. The TIs have to guess. You can kind of guess based on the numbers here, though. 0, 2, 4, 6, 8, 10 means we probably could go from 0 to 10 for X and from 50 to 110-ish for Y. So if I just hit graph and graph, when it's wanting to find the friendly window, I'm going to go to view window. And I'm going to just write down the information that's here. So X then is negative, well, actually, I'm too lazy to write it all down. So I'm going to write negative 2. Never mind. Doesn't want to stay for me. So this is negative 1.67. X max 11.67. Scale 1. Y max. Oh, Y min. Sorry, Y min is 30. Y max is 130. And if I scroll down, scale, they just left it as 1. That's fine. All right. So there's my graph with the friendly window. Here's my friendly window. And it says, determine the function that best represents the data. In other words, looking at this, which of our options do you think is best going to represent the data that we have? Is it going to be a straight line? Is it going to be one of these other cool shapes, quadratic, exponential, square root? We can try a few of them. So if we go to calc, we can look at our linear one and draw it in there. Okay, not bad. Some above, some below, but I think we can hit something better. In order to get this to disappear and not just draw on top, I'm going to have to actually exit back out again and hit graph. So let's try maybe an x squared graph. That would be like the quadratic. So if I do that and draw that in there, oh, that's not bad. Look at that, comes up pretty close. There's just a couple above and below. Exit out of here so I can try again. Exit, exit, hit graph again, calc. Sure, why not? Try cubic, draw it in. Not bad. So some of these are all pretty close. You can kind of choose which one you think fits the best. Play around with it. I'm gonna see. Yeah, not worry about x to the 4. Let's try exponential. Draw that. Again, that's pretty good. I think the best one that we had so far is probably the x squared graph. So that's the one I'm going to go with. If you thought one was closer than that, but I'm going to go with the x squared graph, and I'm going to copy it into my regular graphing window. I'm going to choose Y3 since that's an open one, because I'm probably going to need to do stuff with it later, but I'm also going to draw it back there. They're nice and pretty. So determine the function that best represents the data. Use regression to create a model. So I said quadratic was the best one. Use regression to create a model. Okay, that's what we did. And we want to be able to write down what the model was. So I'm going to exit, 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 exit. I'm going to go back to my graphing menu so I can see. And I'm going to just round these to 3 decimal places. So this is 0.402. And that is my, I guess I could have done it right when I did the calculation, times x. So that's my slope plus Oh, x squared. I forgot about that. X squared plus 2.039x plus, keep scrolling over, 50.071. So that's my model, my x squared regression. That'll work. Now I'm going to use that to predict the number of 100-year-old Americans in 2010. So think carefully about how you would put 2010 into this equation. So I'm going to deselect the ones I don't want. I don't want that one to show up. I don't want that one to show up. But there's my graph, and I might have to check my V window if I go as far as 2010, or make my V window go a little bit farther, and predict when there will be 80,000 100-year-old Americans. Remember that 80,000, all of these are in thousands, so we're just going to type in 80. And if this is years since 1994, my X value that I'm going to put in is going to be 2010 minus 1994. You can figure out what that is. So pause your video now, see if you can figure this part out on your own, then come back and watch the solution. All right, so to solve the first one, we're going to put in x equals 16 because it's been 16 years since 1994. And that gives me an answer of 185.5. So I'm going to say 186 100-year-old Americans. Americans. Predict when there'll be 80,000 100-year-old Americans. So I graph this line at y equals 80, and now I just find the intersection, which tells me at 6.458, which means basically 6 years after 1994. So to find the actual year, I go 1994 plus 6 is the year 2000, is the year when there will be 80,000 100-year-old Americans. A little bit after 2000, but not getting to 2001 yet. So that's it. That is doing linear regression, scatter plots, different kinds of regression actually. This was a quadratic regression on your Casio calculator. Let me know if you have any questions, and good luck with the homework.